In this movie, we will investigate the curve called Witch of Agnesi, which was studied by Maria Agnesi in the middle of the 18th century. So we will start with a definition from Wikipedia. We'll construct the curve using GeoGebra, and then we will find the equation of the curve using Cartesian geometry. So in order to draw the curve, we'll start with defining a slider, which will represent the radius of the circle, as we need to start with a fixed circle. So we start with a circle with radius 1, and here is the equation of the circle. I need the point O on the circle. So I'll take the point at the origin of the coordinate system. We'll relabel the point, which was defined as A. So we'll call it O. And we'll continue the construction by choosing another point A on the circle and drawing the second OA, the line from O to A. Then we'll choose M, the point diametrically opposite to O. It is called B for now, we'll change it later. And the line OA intersects the tangent from B to the circle. From C, we'll draw the perpendicular line to the x-axis, and then from O, the parallel to the x-axis. At the intersection of those two lines is the point which is called in the definition P. In my movie it is called a D, so now we will relabel all the points to match the definition. Next, I want to see what is the path defined by the point P when point A moves around the circle. So for this, I'm going to trace the point P using the GeoGebra feature so that it will draw for me the path by point P. So point P is traced. I want to see the curve better, so I zoom out. And here is a curve defined by the point P. So here is the Witch of Agnesi curve, it's its shape. But what is its equation? So I need to find the algebraic equation followed by the rule followed by the x and y coordinates of the point P on this curve. The rule will give me the equation of this curve. So we'll start exactly by following the construction. Initially, we'll have the equation of the circle with radius r and with a center at the point 0, r. So the equation of this circle is x squared plus y minus r squared equals r squared. Next, we took on this circle a point A so let's consider the point A on the circle of coordinates A, B. A is on the circle, so let's remember that A squared plus B minus R squared equals R squared. This is a pattern between the coordinates of the points A and B. Next, we drew the line OA. So the line OA has an equation y equals mx plus c, c is 0. So this is the equation of the line OA. Our next step was, through that point, called for now B, draw the line y equals 2r. So this line was called BC, and its equation was y equals 2r. Then we intersected the lines, the two lines, and we found the point C. This is what am I going to do now. So we intersected OA and BC. So 2r equals b over ax. Therefore, the x is 2ar over b. Y is, of course, 2r. So we have the point C of coordinates 2ar over b, 2r. Next, let's see how we move towards point P. Now look where point P is. Point P has the same x coordinate with the point C. For now it is called D. So it has the same x coordinate as a point C. And its y coordinate is the same as the y coordinate of A, which was B. So, okay, again, 2ar over b. These are the coordinates of the point P. Now, starting from the coordinates of the point P and from the pattern that they follow, I need to find an equation between A, B, containing eventually only R. So from here we can write that x is 2ar over b and y equals b. I need to eliminate a and b. So xy, because b is y, is 2ar. I need now to eliminate a, and the only way I can eliminate it is finding from here and replace it in this equation. So these are the two equations that we know. As we said, we eliminate a from the first equation by replacing it from the second equation. It is easier to square the both sides of the first equation and get x squared y squared equals 4a squared r squared. From the second equation we can find a squared, so the equations becomes x squared y squared equals 4r squared bracket r squared minus b minus r squared. I will not have b because let's remember from the previous slide y equals b. Therefore, so we will see the fact that y equals b, replace y by b. We now need to make y subject of the formula. We'll open the brackets. We can divide by y, which is not 0, so we get x squared y equals 8r cubed minus 4r squared y. Therefore, y brackets x squared plus 4r squared equals 8r cubed. following that the equation of the curve is y equals 8r cubed over x squared plus 4r squared. We are going to graph this in GeoGebra to see if it matches our previous curve. So we'll check with GeoGebra to see if our curve is correct. As an intermediate point, I would check if the point P that I found before matches a point P here. So I'm going to graph in GeoGebra a point which GeoGebra is going to call Q, having these coordinates, Q. So remember that A is the x-coordinate of the point A, which is called by GeoGebra x-coordinate of the point A. So this is how I'm calling it, such that GeoGebra will know. P is a y-coordinate of the point A. I'm going to change the settings for this point such that I can see how it comes on the top of the point P. So I'm going to change its color and I'm going to make it bigger so that I can see it on the point. So see, it is exactly on the point on the top of the point P. So when I move the point A, the point Q comes exactly on the top of the point P, showing me that my calculations here are correct up to this step. For the next step, I want to check myself. Is the equation that I get correct? So I'm going to plot it in GeoGebra and see if hopefully it will match the blue curve. So let's see. If I plot it in GeoGebra, oh, I see that it doesn't match. Yeah, I mistyped. It's 8r cubed, not 4. Yeah? And now I'd like to change the color and the style of the function so that I see that it comes on the top of the path of point P. So let's the two graphs fit perfectly. So my equation is correct.